Welcome to Master Concepts in Chemistry. In this lesson, we will discuss what you need to know to solve density arithmetic problems. Okay. So first of all, what is density? Density is a measure of how atoms or molecules pack in a given space. So mathematically, we can express density as a ratio of mass to volume. So I will write density D is equal to mass over volume. Okay. So what are the common units you can measure density in? Now, as you've seen, density usually consists of a derived unit. So meaning you always have two different units involved. So since mass can be measured in grams and volume can be measured in milliliters, that means that one unit of density is grams per milliliters. So we can say one unit of density is grams per mils. Also, we can measure volume in cubic centimeters. Okay, so another unit for density is grams per cubic centimeters. Okay. So the question is, since density consists of three different variables, and these variables include density, mass, and volume, it follows that when you have any two of these variables, that is, when you know any two of these variables, you should be able to find the third one by sometimes rearranging the equation. So that means that to rearrange this equation such that you can isolate like m or v, you have to apply algebra. Okay, so let's go over how we can rearrange this equation with respect to mass and then with respect to volume. So as you've seen, since density is written as D equal to mass over volume, this equation is arranged with respect to density D. So remember, D is on top, so it means D over 1. Okay, so density as it is written is just what? Mass over volume. So if you know the mass and you know the volume of your object, you just have to divide it 2. Okay. However, what if we want to find volume? So if we want to find volume in this sense, volume is the denominator on the right hand side of the equation. So keep in mind this is an equal sign. So volume is a denominator on the right hand side of the equation. So that means that we have to isolate volume. So to let volume stand alone, just like the way density is standing alone as D over 1. So to do that, we cross multiply. So we just cross multiply. So I'll just draw the X here, cross multiply. So this just means that I multiply D by V and then 1 by M. So if I do that, I'm going to get dV equals to M. Okay. Now, I want to isolate V. I don't want V to stand with density. So what do? This is an equation, a linear equation. So whatever I do to the left side of the equation, I do to the right side. So I want to isolate V. So I divide here by D and divide here by D. So D cancels D. So that means that my volume V is now isolated with respect to mass divided by density. So if I know my density and I know my mass, I just divide it 2 and I get my volume. Okay. Now we can also isolate mass with respect to volume and density. So we know, again, our density is giving us D equal to mass over V. And remember, D is on top here. So D means D standing on top, and then bottom of it, the denominator is 1 because D is on top, the numerator. So we'll say our density is equal to M over V. But we want to isolate this equation with respect to mass. So what do? We cross multiply again. So we cross multiply just like we did before. So D times V will give us dV equal to 1 times M will give us M. So anything multiplied by 1 is still the same thing. So here we have isolated our mass with respect to density and volume. So as you've seen, isolating mass is not difficult. You don't have to divide by anything because there's nothing standing with M. Even though sometimes you say 1 is standing with M, but 1 multiplied by M is still the same thing. So yeah, so it's always easy to isolate mass because you are not really dividing by anything to have M stand alone. So you just cross multiply and M is just standing alone. So yeah, so it's easy to isolate M. However, as you've seen before, it's difficult to isolate V if you forget that you have to divide by density. Okay, so that is always where some students get into trouble. They always forget to divide by D in order to isolate V. Okay. Now, this is one way of manipulating the density equation with respect to, that is by using algebra to manipulate it. Now, you can also solve problems involving density once you know that density is a derived unit, because density is mass over volume. So that means that we have grams per cubic centimeters or grams per milliliter. So as you've seen, there are two units in one. So grams per cubic centimeters or grams per mil. So that is a derived unit. So that means that you can always use it as a conversion factor. So density value can serve as a conversion factor. So once you understand that, yeah, you don't have to always manipulate the density equation like we've done before. You just have to know which of the ratios of density you need to use. So basically, as you've seen, we can have our first ratio to have the units in this form, grams per cubic centimeters, called A, or we can have our second ratio, which we call B, cubic centimeters over grams. So you see, the first one is gram per cubic centimeter, and the second one is just a flip of the first. Okay, so it's just manipulating your units such that you'll be able to calculate what you are asked to calculate for. Okay, so once you understand that density is a derived unit, yeah, you don't have to always use algebra to rearrange the equation. Okay, so we'll go into how to apply the density formula to solve some problems.